In the search for life beyond Earth, liquid water has long been considered one of the essential ingredients. But actually detecting surface waters on exoplanets orbiting distant stars has proven extremely challenging with current telescope capabilities. Now, an international team of researchers says they've devised a promising new technique that could make identifying ocean-bearing worlds significantly easier. The key is looking at levels of carbon dioxide in a planet's atmosphere compared to neighbouring planets. If a planet has a noticeably reduced amount of CO2, it suggests the gas is being absorbed into liquid water oceans, just as it dissolves into Earth's oceans. Or the missing CO2 could be taken up by a planet-wide biomass of life, similar to how plants and algae consume CO2 on Earth. As exoplanet researcher Julian DeWitt explains, life on Earth accounts for 20% of the total amount of captured CO2, with the rest mainly being absorbed by the oceans. On another planet, this number could be much larger. By also looking for signs of oxygen and ozone, which can indicate biological activity, this new habitability signature could potentially distinguish living biospheres from mere liquid water oceans. This represents a major advance over previous efforts to find habitable exoplanets, which relied on trying to detect the faint glint of starlight reflecting off surface waters, a devilishly difficult observation even for powerful space telescopes. In contrast, atmospheric CO2 levels are relatively straightforward to measure by looking for absorption lines in a planet's infrared spectrum. Beyond just identifying potentially living worlds, the researchers say their habitability signature can shed light on the environmental tipping points that make a planet uninhabitable, like the runaway greenhouse effect that turned Venus into an incandescent hellscape. Understanding these boundaries is critical not just for finding extraterrestrial life, but for preserving the climate on our own pale blue dot.